Hello everybody. Today we're going to be working on reflecting points, anything. You could reflect anything over oblique lines. So let's start with the warm-up. Start by graphing point A, which is at 2, 4, and the line y equals negative x. Did you remember how to graph y equals negative x? Has a y-intercept of 0 and a slope of negative 1. Okay, so we want to reflect this point over that line. I have an idea. I think it should go somewhere over here, right? Remember a couple of things about our reflections, and that is that it has to be on the other side of the line, and it has to be the same distance from the line. And when I say distance from the line, I mean perpendicular distance. So I'm wondering how we could achieve that perpendicular distance. So I'm thinking that, what if I drew in a line, my working line? Remember, we were drawing a working line. What if I draw in a working line that goes through that and is perpendicular? Well, how do I know that it's going to be perpendicular? What should the slope be? Well, if the slope of the line of reflection is negative 1, then the slope of the line that's perpendicular should be positive 1. All right. So now I feel like it's just as much as saying, okay, well, how far is A to the working line along this slope? Well, I've gone along the slope 1, 2, 3. So if I follow 1, 2, 3, that should be where A prime is. So A prime has the coordinates of negative 4, negative 2. See what I did there? Right? Another way to look at that is to say, without the working line, is to just say, okay, well, I know I have to go with a slope of 1, because the slope of the line of reflection is a slope of negative 1. So you could say, well, how do I get to the working line? I went down 1 over 1, down 1 over 1, down 1 over 1. I did that 3 times. So I'm going to do that same thing again. 1, 2, 3, and I'm there. All right, 2 ways. Let's try another one. So now we're going to graph point B, which is at 6, negative 5. Remember, you can pause this video anytime if I'm going too fast. And my line of reflection is at y equals negative 2x minus 3. Y-intercept of negative 3, fall 2, run 1. Fall 2, run 1. All right, I actually want to extend that line, so I'm going to make it a little bit longer. Okay, so this is my line of reflection, and its slope is negative 2. So when I go to draw my working line, Remember, if I'm doing a reflection over this, my working line has to be perpendicular. So my working line, I'm going to draw with a slope of 2. So from here, I would fall 2, run back 1, fall 2, run back 1, fall 2, run back 1. Oh, wait a minute. That's not right. Is that right? You guys would have stopped me in class, wouldn't you? Wait, we have to undo that. Shouldn't the slope of the perpendicular not be 2, but shouldn't it be 1/2? That's better. Because what I was drawing in didn't look like it was going to be perpendicular. That was the problem, yeah? So I would fall 1, run back 2, fall 1, run back 2. Oh, nice. Okay. I'm just going to draw in my working line. So I did essentially 2 moves of my slope, right? Fall 1, run back 2, fall 1, run back 2. So I'm going to repeat the same thing on the other side of the line of reflection. Fall 1, run back 2, fall 1, run back 2. There I am on the line. So there is B prime, if this was B. So those coordinates look like -2, -9. All right. Does that make sense visually? Do you see it? This is really important, though, is that we're going perpendicular to our line of reflection. All right, so let's just summarize what we've done. Obviously, the first thing, if we're doing this graphically, I'm going to graph the point, which is our pre-image, and the line of reflection. And then we start with our working line. We're going to draw our working line. Remember that our working line it's got to pass through the pre-image and be perpendicular to the line of reflection. Okay, those are really, really important. If you do either of these wrong, then you don't stand a chance. Okay? All right. Once we had our working line on there and our pre-image, it's sort of a matter of counting. We're going to count using that perpendicular slope, right? From the pre-image until we get to the line of reflection. Right? Until we get to the line of reflection, right? So, and in each of these cases, both examples that we just completed, we actually had a perfect point of intersection between the line of reflection and our working line, that perpendicular working line. We had a perfect point of intersection. And what I mean by perfect point of intersection is that it's a point that landed right on the lattice. All right, so it was nice. It was a nice point. All right, and then once we counted, we got to that point of intersection. Then we repeated the count on the other side. Of course, along the working line. All right. the image. Visually makes sense? Okay, so then the big question is, will this method always work? It will, provided that we end up with that good point of intersection, right? Between the working line and the line of reflection. That we end up with that point of intersection that's on the lattice. You know, that's when this method will work. Also, when we can actually graph it, if we actually have graph paper and all of that, all of our supplies, the tools that we would need to achieve this. But we don't always, right? So we really should come up with another strategy, one that will be more reliable and... Oh gosh, that was loud in my ear. I don't know if you guys heard that at all or not, but that was super loud in my ear. Okay. So here's another way to do this for when this graphical method doesn't work. We have to remember a couple of things, right? And I know I'm just keep repeating myself, but it's worth it. The first thing to remember is that we have to draw our working line perpendicular to the line of reflection. Okay, it has to be perpendicular. And the other thing about a reflection is not only are we perpendicular, but then we also have to have the same distance of the pre-image and the image to the line of reflection. Okay? All right, so I'm just going to go back to the front side for just a minute. Look at this. Noticing something about that point of intersection, right? When we're talking about this point of intersection, this one right here. Well, if I look at the segment that connects B to B prime, what's true about that point of intersection? If I look at the segment B, B prime, then this here is the midpoint of that segment. Is that true in the first one? If I look at the segment A, A prime, then this right here, is that the midpoint of that segment? It is. Okay, so let's see if that helps us. I'm just going to write it that way. A prime. I'm going to call it A prime. A being the pre-image, A prime being the image. All right, that's a really important piece. It's the midpoint. Okay. All right, so I sort of have a plan then. I'm going to try one without graphing. I've got this point C, I've got the line of reflection, and I want to find the coordinates of C prime after the reflection over this given line. All right, so I think I have a plan. My first step, is going to be to write the equation of my working line. Remember that the working line is perpendicular to the line of reflection and passing through the pre-image, in this case, C. Okay, so if it's perpendicular to the line of reflection, that right there is going to tell me that my slope should be opposite reciprocal, should be -3/2. And passing through C, well, passing through C, this is my point, -1, 2. I think I'm prepared to write the equation of the line. So the equation of the line should be y minus 2 equals -3/2 x plus 1. I just wrote that in point slope. Okay? All right. So now I have the equation of the working line. Terrific. If I could find the point of intersection between the working line and the line of reflection, I'm just going to take you back visually. If I could find this, right, the thing I keep circling, that point of intersection between the working line and the line of reflection, that's going to give me the midpoint, which is helpful. Then I know how far my pre-image is from the line of reflection. So I'm going to do that. I'm going to find the point of intersection. All right, so my two equations are this. I have y equals 2/3 x minus 6, and I have y minus 2 equals -3/2 times x plus 1, right? And you're seeing it now. This is, of course, a system. So it looks to me like the most efficient method to solve the system would be substitution. I'm thinking I'm going to take this and just substitute in there. So 2/3 x minus 6 minus 2 equals -3/2 x plus 1. Here we go. You know, I think I'd like to get rid of the fractions. As much as I like them, I think I'd like to get rid of them. If I multiplied both sides of the equation by the lowest common denominator, I've got a 3, I've got a 2. So if I multiply both sides of the equation by the lowest common denominator, which is a 6, I think I can clear those fractions out. So 6 times 2/3, that's going to give me a 4x. And 6 times 8 is, of course, 48. And 6 times the -3/2 should give me -9x. And that's a -9. Okay, keep plugging away. I'm going to add 9x to both sides. I'm going to add a 48 to both sides. Oh, cool, I can see it. X is 3. All right, now that I know what x is, I'm going to go ahead and I'm going to solve for y. So y equals 2/3 x minus 6. Okay. So that's 2 minus 6, so y equals -4. So my point of intersection is going to be 3, -4. All right, now keep in mind, don't lose sight of what it is. This point of intersection between the line of reflection and the working line, I'm going to take you back to the visual again, is this. And that's the midpoint. That tells me the distance. All right, so when I call this the point of intersection, what I'm really calling it is the midpoint. It's not that it needs to be crossed out so much. It's just that it'll bring you to the idea that it's the midpoint. All right, we're almost done. I know I'm running out of room, but I can still achieve this. I have enough space. It's not that much left. So now I'm going to apply the midpoint. So I'm going to use the midpoint formula to find the image. All right. So in this case, I know the midpoint and I want to find the other endpoint. So what I have is, I have in my midpoint formula, I have one of my endpoints, which is C. So that x coordinate plus the missing x coordinate, average. And then I've got my y coordinate that I know from C, plus the missing y coordinate, which would be my image y coordinate. And that equals, I know the midpoint. Yeah? Okay. So this part is going to equal the 3, and this part has got to equal the -4. Agreed? All right, so I'm going to take this and set that equal to 3 and solve. So I'll multiply both sides by 2, and then I'll add a 1, so I get 7. Then I'm going to take the y coordinate piece and set that equal to the -4. Multiply both sides by 2, subtract a 2. Okay, so just go back and think about this for a second. -1 plus 7, let's see, -1 plus 7, that's 6. 6 divided by 2 does in fact give me 3, right? You see where I'm going with this? So I think I've accomplished it. My image point is going to have coordinates 7, -10. What I did, just kind of work it backwards now, what I did is in using this midpoint formula, I've said that the midpoint between C, my starting, my pre-image, and C prime, what I just happened to find, was actually this 3, -4, right? And that midpoint is the point of intersection between the line of reflection and the working line. We got it? Okay, seems like a lot, but let's just recap what we did. We found the working line, right? Just like we did when we drew it in on the first couple of examples. We did the working line, which is perpendicular, passes through the pre-image. Then we found the point of intersection, which is the same thing we did visually when they worked out graphically, right? We found that we counted to that point of intersection. Well, in this case, when we're doing it without the graph, we're going to find that point of intersection. Once we know that point of intersection, we know that that point of intersection happens to be the midpoint between the pre-image and the image along the working line. So we applied the midpoint formula and just worked backwards. Okay? Let's practice. Let's just do one more, and then you guys can go ahead and start working on your homework. All right. Remember, first step is going to be to write working line. Get your working line. Okay, so the working line is going to be perpendicular to this and pass through that. So the perpendicular slope is going to be a -1/2, and my point is 14,4. So my equation is going to be y minus 4 equals -1/2 x minus 14. At this point, if you want to try this on your own, that would be terrific. Just go ahead and pause the video, try it on your own, and then come back, restart the video, and see if you did it all right. Okay, there's my working line. And now what I need to do is I need to find the point of intersection. Remember, that point of intersection is going to end up being the midpoint. Okay, so my two equations are y minus 4 equals negative 1/2 x minus 14, and y equals 2x minus 4. And this one's set up for substitution also. So here's a trick. Instead of distributing the negative 1/2, right here, to kind of keep the fractions out of the mix here, I'm going to multiply, excuse me, I'm going to multiply both sides by 2. Now watch it, watch my signs. Right, because I didn't get rid of this negative. So I still have a negative left over that I have to distribute to the x in the negative 14. Okay, if you don't like that, if you're like, whoa, what the heck just happened? That was some magic that I don't understand. Go ahead, distribute the negative 1/2 first, and then try and clear the fractions. It's actually not a really bad fraction to clear. You could leave it for a while because it's a half. So anyway. All right, add the 6, add the 16, another nice number, so x is 6, and if x is 6, then y is 2, 6 is minus 4, so y is going to be 8. So 8, 6 is our midpoint. All right, last step is to use the midpoint formula to work backwards. We know the midpoint, we know an endpoint. We're going to put that together to solve for the other endpoint, which is going to be our image. All right, so from the average of 14 and our missing x value, and the average of 4 and our missing y value is going to equal this 8, 6. So remember, this part of it is the x coordinate, and this part of it is the y coordinate. So 14 plus x over 2 has to equal 8. So 14 plus x is 16, so x equals 2. And the 4 plus y over 2 has to equal the 6. So it's going to equal 12. So y has to equal, wait a minute, did I copy that down right? Oh shoot, I did something wrong. Do you know what I'm thinking? It occurred to me. I was like, wait a minute. This x value of 2, that doesn't really make sense. That doesn't feel like it's far enough. Look at what I did. Go back to the midpoint. Look at what I did. Do you see it? X is 6 and y is 8. I wrote it backwards. All right, sorry. I got to go back. I have to fix this. Mistakes are good, right? They're frustrating sometimes, but they're good because I was thinking about it and I was thinking, gosh, my answer isn't making sense. It's just not. I mean, it's not that 2 was a bad number, which made me feel like kind of icky about it. Like if I got 2.1365, that might make me feel a little bit icky about the answer. But it's that it didn't seem far enough. And I want to show you this for a couple of reasons. I didn't purposely make the mistake, first of all. But it's important that you see that I do make mistakes. And that I'm thinking about the big picture. I'm thinking about, does my answer make sense? Right? So that then I can go back and say, wait a minute, I made a mistake. All my synapses are firing, my brain is growing, aha, yeah, all that good stuff, right? Okay. So let's see, I've got to erase this. Fix that. This is going to be 6, 8. That one goes with that. That one goes with that. Let's just take it back to there. Okay, going back, redo. Yeah, that seems better. -2 seems better, right? A little bit farther away. That seems more appropriate. Okay. -12. Yeah, that's definitely more reasonable. And this is the location of D. That looks like a P. D prime. Okay. Well done. We made it. Okay, so now if everything's good with the video, you understand, that's terrific. You can work with your pods and start working on your homework. If you still are feeling a little bit like, yeah, I don't know what's going on, I would suggest you take a look at the section in section 2.4 in your textbook where Mr. Esberg goes through the explanation. There are a couple more practice problems that you can try as interactives. So you can try it in your book, and it's like a little whiteboard. It's a split screen whiteboard that you can try in your book, and then there are answers you can check. So if you're looking for more practice, whether it's now or later, you're looking for more practice, maybe getting ready for the test or something like that, I strongly suggest you take a look at section 2.4 in your textbook. Okay, that's it. Have a great weekend, everybody.